Hello friends, welcome to Unacademy and welcome to today's session. In this session, we are going to discuss about the very important numericals on process synchronization with various varieties. So which starts with concurrency and race conditions and many others we are going to solve. So increase all your energy and try to solve all the problems. If there is any problem you find, then I'm going to help you out in solving them. So before going into quiz, let us say our anthem, crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. About myself, Srinivasarao Sir, having 17 years of GATE experience in various subjects in the CSE stream. I also had industry experience as a system analyst and database admin. You too also can have if you learn good kind of stuff and if you crack IIT, NIT and Central University. Throughout my journey of GATE, I taught in many premium academies including GATE Forum, GATE Academy with high success rate. Many of my students are working as a topmost software engineers in MNCs as well as many are working as a GATE mentors. Really, I am very proud that my students are also GATE mentors like me. Why can't you? Question mark. You also please join after cracking IIT, NIT or Central University admission. But please sure that before to crack IIT, NIT, you all see that admission is very much important. Unless and until you take a proper training, you cannot able to get or you cannot able to crack any kind of GATE examination. This training meant only for increase your speed, not to teach complete. So you people might be aware of subjects. We are going to mandate and we are going to provide a speed and accuracy to you. So please be sure that if you want to take admission, you have to take admission. Just use my referral code to get and enjoy the discounts which are offering by an academy people. So there are two kinds of subscriptions, 12 months and 24 months. This is a 12-month subscription. You will get it for 22,500. Apart from that, many redeem points are also there. And this is a 24-month subscription. You can get that. Then you are going to get it for 27,000. All third years and the second year students, please opt for 24-month subscription. There you are going to get full complete pack for the upcoming 24 months. So therefore, you're going to get live quizzes, live sessions, and any kind of important tasks are going to be cleared in this 24-month subscription. You're also going to provide many kind of test series. Test series will give you lot of impact and you can able to reduce your rank. So let us start our session. Subscribe to Unacademy YouTube channel. Let's crack GATE CSE. Use my referral code and hit the bell icon for the latest notifications and updates. Let us start, all of you. All the best to all of us. This is the first question. A critical section is a program segment. So choose the answer. I'm going to give you 30 seconds in this. So good evening all of you. So those who joined today, Vanilla, Ajay, and many others, Surabhi, Samiksha Jain. Good evening to all of you. Take the poll now. So 30 seconds time. Just I need speed and accuracy, both required. You need to balance it. So the people who are doing on YouTube live, please you also share your answer through the comments. If there is any doubt, we will discuss it. So let us take. So what is our option? Our option is option B. And don't type your answers, please, all of you. That's my sincere request. I will tell you, then only you please reveal the answer. This is the live program is going on. Thank you for all your support. Let us take the second question. Let's crack it. Please understand carefully. Analyze the question properly. Don't worry and be panicked by seeing the length of the question. Try to observe the logic of the question. So what is the final value of D after executing the processes? And see that the preemptions are happening before write operations of your processes. So what is the final value of your D when it is assigned to 100? So I'm starting the poll. Be ready. So I'm going to give you 60 seconds time. Very good, all of you. Good work. Good work, Vanilla. Don't give up. Try, please. Don't give up. Last 5 seconds. So thank you very much for all your answers. Now you tell me. So any doubt, friends, here? Anyone you want me to discuss, I will discuss. So the answer is, so some are guessing 100. Do you have any objection with this 100? So please understand carefully. The initial value is 100 here. For example, if P1 is executing, exactly after D is equal to D plus 20, then there is a preemption from P2 and P3. Therefore, what happened? Immediately that is going to be passed here. So this is not updated. Please understand carefully. This is just a formula only. Now, unless you do write operation, it is not being done. Now you observe here, again he is performing 100. So it is being done 120. Again there is a preemption because before write operation there is a preemption from any of the process. Therefore what happened? Again this value is being cancelled. Again he has come. He is doing 120. Again there may be a chance of before write operation. Therefore what is going to happen? You cannot able to do any kind of modification as there are some preemptions before your write operations. Unless write operation is done, it is not updated your value. Clear? So let us go to the next question. This is your third question. Yeah, come to next question. Now they are executing concurrently. X is equal to 0, y is equal to 0. So he set x is equal to 1 and y is equal to y plus x. And then again there is a begin y is equal to 2, x is equal to x plus 3. then concurrency is end. So these are the two processes. One is executing from here to here, and the other one is executing from here to here. He's asking what will be the x and y values by taking a preemptions. I will show you the schematic diagram of this. Once please observe. This is given one of your previous gate question, very recent gate question. So I'm telling you like this. There is x is equal to 0. Please understand the schema, and y is equal to 0. So there are one process is executing like this and other process is executing like this. So one process x is equal to 1 and y is equal to y plus x, and other process is y is equal to 2 and x is equal to x plus 3. But they can able to execute concurrently. This I can execute concurrently, this I can execute concurrently because they are under the braces of concurrent begin and concurrent end. But you see that this is a statement 1, this is a statement 2 which are there in process X. This is statement 1 and this is statement 2 which are in process Y. You can do interexchange, but internal swapping must not be done. So what is the final value of X and Y? So he is asking which of the above claims are true. Is it 1 and 2 or 2 and 3 or 1 and 3 or 1, 2, 3? So please execute and tell me. Let us start the poll. Very good. Very good. Aish, Mayank, Vanilla. So now tell me, friends, any doubt in this? If you no doubt, I will go to next question. Can I go to next question? Yeah. Tapasvi Chakravarti, we will discuss that point after completion of questions. So come to next question. Now see this question properly. A lock is a shared variable initialized to 1 and the processes are executed with the following piece of code. So which of the following claims are valid as far as above code? So fourth one, please be careful while giving answer. Think that every bit is important. Very nice. And see that this block is atomic, which cannot be divisible. Last 5 seconds. Yeah. So many of are saying, so different answers are coming. Then let me explain this. So initially shared variable is equal to lock is a shared variable among the process which is initialized to 1. So 1 is nothing but lock is already done. It is a true. When it is a true, then what is going to happen? While lock not equivalent to 0 semicolon. So what is the value? 1. So 1 not equal to 0 semicolon. What is the meaning of that? It is satisfying true. Therefore, it is going to be under waiting. So you cannot able to come down to the next line. Therefore, what is going to happen? You execute any kind of a process, not only X, any kind of process you execute, we don't mind. Because see the condition, you are coming with a lock is equal to 1, that means it is a true. Therefore, the condition is always going to be satisfied here, 1 not equal to 0, yes it is true. Therefore, none of the process can able to enter into your critical section. So that's why your lock value is supposed to be what? Initially not true. It's supposed to be initially what? False. Clear? Clear everyone? Yeah. So therefore, none of the process can access your critical section. So come to next question. This is question number 5. Please see that there are no semicolons at the end. Please understand. There are no semicolons at the end. If the condition is satisfied, it enters into the loop. If the condition is not satisfied, it is not going to enter into the loop. And he said that variable p, variable q are initialized to false. This is a right. This is a right statement. Initially, they are coming with false. So please analyze this question properly. He is asking mutual exclusion, progress, and deadlock together. Let me start poll now. Good work, Surabhi. Don't give up. Try, please. Now tell me, friends, any doubt in this? Can I go to next question? Any doubt in this? Yeah. So I can go to next question then. So I'm going to next question. This is your fifth question. Sixth question. They are using critical flag, which is initialized to false. and this is the piece of code is executing by processes P1 and P2. So among the two statements, which is true, which is false. So take the poll now about the sixth question. Very nice. Now tell me friends, any doubt in this? So let me tell you like this, if you are having a doubt, so initially this is giving a false. So if process 1 and process 2 both are executing the piece of code, so let us say that initially the value becomes a false and he is checking critical flag is equal to false. When this is a false, then he can able to set the flag that is a critical flag is equal to true. Then he can enter into critical region and he is setting a false here. And if the say other process is going to give some kind of a preemption, then what will happen? So when P1 is in critical flag is equal to false, because initially your flag value is equal to false, exactly preemption came by P2 here. Therefore, what happened? The P1 code becomes now P2 code only. Same code is executed. Now he is also having, he is also reading the value of your flag is false only. So if critical flag is equal to false, yes also, yes, he is also getting the critical flag is equal to false, and both sets to next line true and both enter to next line. Therefore, what is going to happen? Both the process can enter into what I meant to say critical section. Therefore, both at a time P1 and P2 can access a critical region concurrently. So whenever somebody can enter into critical section, then there is no concept of a deadlock. Deadlock concept means both are waiting to each other to enter into critical section. So come to next question. So think properly. So please see that this box is atomic. He need not say, he need not tell you all these things. You need to understand whenever there is a box is given. So let us take the poll. So 30 seconds only I will give you. Very good. So now you are all clear what is the difference between this example and previous example. So now we'll understand the difference between both the examples. Oh, good. Now this is very simple. As this variable becomes a false, when variable becomes a false, then what is going to happen? As this is a what? Atomic, you cannot give any kind of what? Preemptions there. Therefore, we can able to say that only one process can able to access your critical section. So come to next question. This is question number 8. So S1 value can be true or false, and S2 values can be true or false. So using the two process P1 and P2, what will happen? So take the poll now. Yeah, very nice. So any doubt here, friends? One C. So one of the audience question from YouTube. Please be wait. So here S1 can be true or false, and S2 value can be true or false. So now I'm saying, let us assume that S1 is coming with true and S2 is also coming with true. Then what is going to happen? Let me execute process P1. So S1 is equal to S2. Yes, both are true only. So when it is a true, I am not giving any semicolon over there. So as there is no semicolon, if the condition satisfied, then I can able to enter into critical section. So that means what? If S1 is equal to and S2 is equal to true and S1 is equal to S2 is equal to false, no problem. So at least one process could be inside the critical section. Therefore, what is going to happen? No starvation to P1 and P2, because if the condition is a true, both conditions are true and both conditions are false, then P1 can be inside. And one is a true, S1 is equal to true and S2 is equal to false, then this condition will be satisfied. Then P2 can be inside. Why? Because we are saying S1 not equal to S2. That means if you take true and false, no problem, P2 will execute. If you take both true and both false, no problem, P1 will execute. Therefore, there is no starvation to P1 and P2 here. So let me go to next question. Ninth question. Observe carefully, study the piece of code. So let us start the poll. Very good. Abhishek Mohanty, Rama, Vanilla, Ayush. So very nice. Any doubt, friends? Any doubt in this? So in this case, what is going to happen? We say S is equal to 0 here. And I am not saying that no, previous is a different. Previous is a what? Atomic. Please understand carefully. Sameksha, previous one is a atomic. This one is not atomic. because I have not said that they are indivisible. They are divisible as I am not saying any kind of box over there. Therefore, they are individual. Therefore, I can give preemption before while or after the lock, no problem. Therefore, what is going to happen? Please understand. So, whenever the process X executes the while condition, that lock is equal to 0 is coming. Okay, no problem. Lock is equal to 0. So while lock not equal to 0, I am coming with the 0 value, hence I can able to enter. Before you are making a lock, if somebody preempt you, process Y, if you take, and he also got the same piece of code that while lock not equal to 0. Therefore, what happened? He is also going to get the value as what? 0, because he is not yet set. Preemption came. Therefore, what happened? Y also can be inside as well as X also can be inside. If I am take a process Z, no problem. It also can be inside. Why? Because you are giving a preemption just after while condition before setting lock is equal to 1. So therefore, all process can enter into what? Critical section. Okay. So come to next question. This is a 10th question. So if you feel I am going bit speed, please tell me, friends. I will go slow. So he is taking a allow variable which is initially false. Now all of you listen carefully. Samiksha and others, please listen carefully. He said very clearly now, S1 and S2 are indivisible. What is the meaning of S1 and S2 are indivisible? You say, now this is a completely what? Atomic. Now you need to understand this. Okay? Now take the poll, 10th one. You can see your scoreboards, friends. I am showing to you. So any doubt you have, tell me. Any doubt in this? Very similar to previous question only. Very similar to previous question, but he is asking different answers. Is there any deadlock chance? Is there any mutual exclusion? Is there any violation to progress? Is there none of the above? And now you see what is our answer finally. So they are running concurrently and preemptions are allowed. Now you tell me what is the answer? So only one process can enter into critical section. As we are making that what it is a atomic section. Therefore, we know that it is very similar to the previous program which we done with what I mean to say atomic execution. So only one process can allow into critical section. Okay. So whenever one process is allowed into critical section, we are satisfying a mutual exclusion. Therefore, this option is wrong. And I can able to do multiple number of times this. Therefore, it is also satisfying progress. So that's why these two options are wrong. And there is no deadlock chance because at least one of the process can be inside your critical section. Therefore, your answer is what? None. So come to 11th question. This is 11th question. So let us take the poll. 11th one. Good, Jaya. Jaya Shanjishri, Abhishek Mohanty. Very nice, all of you. Please think properly. Mutual exclusion is not guaranteed in mutual exclusion is not guaranteed in. Yeah, very nice. So it's a very simple. Mutex means it guarantees mutual exclusion. Binary semaphore is nothing but mutual exclusion, it guaranteed. The only one you say that counting semaphore, because your semaphore value can be negative as well as semaphore value can be positive. So because of positive, there may be a chance of that multiple process can be inside your critical section. Come to next question. 12th one. So consider a semaphore S. S is equal to 0. What is the meaning of 0? If the value S is equal to 0, what is the meaning? Yeah, very nice, friends. Good work. Good work. So S is equal to 0 means 1 will become what 0 here. So when 1 successfully you are doing a down operation, then you can say that so already one process is in critical section. Come to next one. So please understand. So 13th question. So it is a very simple. S greater than 1 means a positive value. As we discussed that positive values are allowed in only one kind of a semaphore. We know that. Yeah, it's not in binary. It is in counting semaphore. Come to next question. So binary semaphore, you are going to have only two values 0 comma 1, but that is available in counting semaphore. So 15th question. Observe carefully. So he's talking about this. I'm underlining. So take the poll of 15th question. Very nice. Almost all done. Excellent, excellent. Very good. Excellent. So the answer is you can say that high priority tasks can be preempted by low priority or medium priority. Then it is a concept called priority inversion. So come to next question. So 16th one. So as per counting semaphore concern, negative value is nothing but we know those many number of process is inside suspended list. So that's what the meaning. When s is equal to -1 indicates that this is the advantage of your counting semaphore. We can come to know that number of processes which are there in your suspended state. So one process is in suspended state. Come to 17th question. So I'm giving you challenge to all of you. This is a challenge. Those who are on live, those who learned some of process synchronization from me, and those who learned from outside. So please answer to this question. Really, this is a challenging question. So let us take the poll of this question. So he is asking what is the maximum value of your D after execution all the processes. Initially, it is defined with 100, and he is asking the maximum value of D after execution all the processes, and the semaphore value is given 1. So ready? So we are going to start. So I'm giving you 60 seconds because some students are YouTube live. I'm also focusing on them. If you would have completed this within a period of time, please relax. Think that what kind of questions we are going to get in the next. So any doubt on online, you please type through chat. I can respond. Yeah. So if my poll is wrong, don't worry. You and me will discuss. Sometime there may be a chance of overlapping of answers. But some are saying 120, some are saying 130. Why it is 130? Nishu Kumar, why 120? Sameksha, don't worry, मैं हूं ना. So you and me will discuss together and finalize the answer. Abhishek Mohanty and Tapasvi, what is your answer? Abhishek Mohanty and Tapasvi, 130. Tapasvi, 120 plus is equal to 130. Hmm. Oh, once let me cross check, please. Yeah, you're right. Kopal Rama, superb. You're thinking nice. Good, good. Please, all of you, listen here. So here D is equal to 100. This is one of your previous gate question, 2018 gate question. So D is equal to 100, but you observe carefully. I am controlling them using semaphore. This is very, very important. So semaphore initially S is equal to 1. So I am doing a weight test and please understand, this is not D. Yeah, this is not your direct previous gate question. I changed it to semaphore controlling. Therefore, what is going to happen? You cannot come down because I am falling in a sequential order. Either you follow 1 followed by 2 followed by 3, or you follow 3 followed by 2 followed by 1, because we are doing. Yes, this is, that's why you see that only one process I can execute at a time. For example, I am saying that 100 plus 120, you can do it 120. After that, I am doing minus 50, then you are going to get 70. After that, you do plus 10, then I am going to get 80. Reverse you come. 100 plus 10, 110. 110 plus 20, 120, 130, minus 80. 80 you are going to get. So you see that any of kind of a sequence you follow, you are going to get six sequences. Six sequence you are going to get. One followed by three followed by two, and other one two followed by three followed by one, other one two followed by one followed by three, and three followed by one followed by two, and three followed by two followed by one. No other you will get. Therefore, any type you execute it, I don't mind. You're going to get the highest value is only one. Yeah, you cannot do context switching also because I'm going in a proper perfect way. I'm using only one semaphore control variable among all the processes. Clear, all of you? So, yeah, come to next question. 18th question. It's a very simple to all of you. You can crack it like anything. Let's crack. So, 18th question. Observe carefully. Please analyze the question. Don't look at the gate questions, please. I'm changing the logic as far as your and my concern. We are going to do different problems. So 18th question, study the question properly. So very nice, very nice. Good work. Superb. You're all good in semaphore. So initially S is equal to 0, T is equal to 0. So weight of S is nothing but decremental only. You cannot decrement to this. So you are going to be underweighting. And this also T is equal to 0. You cannot able to do decrement here. So therefore you are going to be underweighting. So nobody is there to wake up you once after calling your weight function. And so both the process cannot able to enter into next line. That's nothing but critical section. And so your answer is what? It is not at all these options, only one. That is a what? No process can enter into what? Critical section in this case. Very nice, all of you. So come to next question. 19th. Okay. So analyze the question properly. Please look all the corners. Please look all the corners. This is very, very important. Initialization is very, very important. So let us take the poll. 19th question. Superb. Excellent, all of you. So the people Audience who are watching through YouTube, please you also can type your answer. So if you know your answer, you just cross check with me finally the answer which I am going to give you. If there is any doubt, you can chat with me. So all of you, excellent. All you have given correct answer, 100% accurate now. Nishu Kumar, wow, all are very good in semaphores now. So the answer is that you guess. What is that? The 19th one, we guess that both P1 and P2 can be inside the critical section because one I can make successful down, one I can make successful down. He can enter next line, he can also enter next line. So come to next question, 20th. Study the question properly. See, the initialization value is very, very important. Don't type answer, Nishu Kumar. 20th. Well, friends, so please understand carefully. Now, look at once here. So, once see, please see again. S is equal to 1, T is equal to 0. So, P2 cannot enter. Why? Because you are coming with the 0 here. So, P2 cannot do successful decremental operation. Therefore, what is going to happen? Please see. He cannot enter into critical section unless and until somebody has to wake up you. So who is that somebody? The somebody might be P1. Please see. So P1 is using a control variable 1. So 1 I can do successful down so that I can enter into critical section. As soon as I enter into critical section, then I am making signal T. Signal T means what? He is worrying about the process 2. So T value initially 0 and the signal means incremental operation, then 0 becomes 1. Therefore he got the chance. Now value 1 becomes 0. Please understand. And value 1 becomes 0, then he can enter into critical section. Yeah. So please understand. Now what is going to happen? Please understand. After completion of P1 critical section, please understand. P1 first issue weight of S. Then after that, P1 is doing critical section. After critical section of P1, then P1 is using the signal of T. So when you are saying signal of T, this time the P2 will get a chance. He can able to do weight of T now. So after doing weight of T, before P2 doing weight of T, the P1 is out of critical section. Please understand. Please understand carefully. Before P2 is starting his weight operation, P1 is already come out from the critical section because he already raised a signal of T now. So therefore, I cannot go now. Why I cannot go now? S value is now, you made it 0. So it is not going to be 1 to do the progress once again. Please understand. To do the progress once again, S value is supposed to be set to 1. But here who is going to set to 1? Somebody is going to set to 1. So P2, after accessing your critical section, then P2 is doing signal of S. So signal of S is nothing but now he is giving a chance to what? P1. So you are going to see a concept of what? Strict alteration. So we are doing a strict alteration with the help of a small semaphore code only. So I can say that mutual exclusion is satisfied, only satisfied. It is not satisfying both. Progress is not satisfying. And both P1 and P2 can access critical section at a time. Please understand. That's the point. At a time. Both P1 and P2 can access critical section means it is a what? At a time. You need to think it like that. So it is not possible at a time. Okay. Clear? Nishikumar? Yeah. Come to next question. 21. This is your 21 question. Very, very famous question. This is in GATE and any kind of examinations. Analyze the question properly. So semaphore SC is initialized to 10. So let us take the poll. 21. Be ready. Let's crack it. Yeah. Very good. Sameksha, Shurabhi, Abhishek. Very good. Tapasvi, Jaya Shanjishri. Good work. Where is Ajay Talwar, my friend? Yeah, very nice. Any doubt here, friends? No doubt, na? Any doubt, friends, here? He is in coverage area only, Ajay, Sameksha. He is in. He never miss out. Now see, we have got the answer. The answer is nothing but what? So that we want to see that two process is supposed to be inside the critical section. That means already 4 signal operations are given. Signal means incremental. It is a 14. Now we want to see that two processes are supposed to be inside the critical section. Two process you want to say that inside the critical section means your S is supposed to be -2. You want to say that S is equal to -2, then how many weight operations are required? If I am saying weight operations are nothing but decremental operation. So -12, if I am saying that, then what is your answer? So if I am saying how many weight operations required, so what is the answer? If I am doing 10, if I am doing 10, what is going to happen? So yeah, then so I want to see that S is equal to final value -2. But you want to say that two processes are in critical section. So two processes are in critical section in the sense we say that S is equal to +2. So he is telling about two important things. So one is critical section, how many can enter, and the other one, suspend list, how many can enter. So suspend list means we want to see that negative value. Critical section means we want to see that positive value. So here we got a +2, hence it's fine. That's what it's a D. So come to 22 question. Yeah. So observe carefully this piece of code. N processes. This is the point number 1. Two semaphores A and B initialized to 1 and 0. A is equal to 1 and B is equal to 0. And see the code section. A shared variable is initialized to 0. Now you observe carefully. In a particular program, please understand, in a particular program, there is a code section as well as there is a queue section. Please understand. In a single program, some code for P and some code for Q. This is how. So I want to execute this code section Q. So he has given some kind of information. Okay. So please understand carefully four important options. It ensures that n-1 process can be inside code section P at a time. It ensures that at most two processes are inside the code section Q. Code section Q means this one. It ensures that code section Q is nothing but nothing is there. Please understand. Some content is there. Please understand. Q code is nothing but some content is there. That's it. It may be anything. It may be ABCD. It may be something else. We don't mind. But could you able to reach to Q or not? He is telling you. And option C, it ensures that no process execute code section Q before every process has finished code section P. Please understand. So it ensures that all process execute code section P in a mutual exclusive manner. So what is the correct option? You see that code section Q may consist anything. His main intention is only code section P only. And your semaphore values are initialized to A is equal to 1 and B is equal to 0 and count value is initialized to 0 here. Okay, so think properly. This is one of your very recent GATE question. So 22nd. So think properly. I'm going to give you some extra time. Very good, Tapasri. Think properly. It is a programming. That's it. Logic, programming logic. Bus. So you please assume some n value so that you will understand. Assume some n value. We don't know what is the n. You take n value, then you start work. So let us see once, please, all of you. So let me explain. If I am taking n is equal to 2, please understand. If I am taking n is equal to 2, so first let me execute P code. So I'm talking about n is equal to is nothing but two processes. Please understand, two processes. First P1 is executed. So n is equal to 1 I am starting. N is equal to 1 is nothing but P1. So weight A. When I am saying weight A, then 1 becomes 0. All of you observe carefully. Then if other process is given a preemption, it's not possible to preempt. Why? Because you cannot able to reduce. Please understand. You cannot able to reduce this because semaphore is a controlling here such that You can able to go in a proper sequential order. First process, then it will give control to second process. Even you give preemption after wait, it is not possible. But before wait, you can give preemption. That means what? This complete piece of code, please understand, this complete piece of code is under protected. So it is nothing but a critical section. Critical section is, it is not the meaning of an object. Critical section may consist of some piece of code or line of code which is under protected using a wait and signal operation. So I'm starting here wait and I'm raising here signal, which means that this complete code is under protected. Protected means even others are trying to do any kind of a preemption, it is not possible, as they are supposed to be executed in atomic nature unless and until you reach to signal of A. So finally we understand that here to here it is under completely protected. So okay, so only one process can be allowed, either N1 or N2, as I am taking two processes. So 1 becomes 0, your count is equal to count plus 1, so it is a 1 now. Now you tell me, if count is equal to n, I said that n is equal to 2, so 1 is equal to n. Please tell me. So count is equal to n. So no, therefore when it is no, then what is going to happen? Please understand. What is going to happen? So you cannot able to do signal of B. Please understand. So what happened? Again you got what? Signal of A only. Signal of A means now your 0 becomes what? 1. Once again I go back. Please understand. Once again I go back. This time what will happen? Second process will come into the picture, that is 2. Now you see that is going to try now. So 1 is equal to 0. So your count already it is a 1 now. So count is equal to count plus 1. It becomes 2. Now please understand. 2 is equal to n. Yes, it is true. When it is a true, signal of B means immediately you are jumping here. So when you are saying signal of B, now I can able to do what? Weight of B. Weight of B, initially B is 0, now I made it a 1, so 1 becomes 0. Then signal of B, which is nothing but what? 0 becomes 1. Now I can enter into a next line. So what is the meaning of that? See, please see that. Unless and until it ensures that no process executes code section Q before all the process has finished what? Code section P. This is your answer. Okay, friends. So let us go to 23rd question. I am challenging to all of you, those who are on live. This is one of the beautiful question. I took almost all some time to design this. Really, you need to, what I mean to say, appreciate me that I am keeping much effort to you, only for you, right? So please understand this question properly. If you able to do, anybody, if you able to do, really you are great. You are great in process synchronization. I am certifying that. Okay, please think it. Please see, observe. So I am not going to say anything. Analyze this question properly. So I will give you, please work it out on the pen and paper. Then I will start the poll. Don't type your answer, please. So here CS stands for critical section. Critical section. This is a critical section. Up means signal operation, down means wait operation. So PA means critical section. It can be anything, right? So process, it is say that A resource, Q resource. P object A it is accessing, Q object A it is accessing. We don't mind what is there inside the critical section, just he entered into critical section, which may consist of some piece of code which must be protected. So ready, all of you? So be ready. 23rd question. Yeah, very good. Ajay Talwar, Surabhi, Abhishek Mohanty. Very nice. Rama, Mona. Very nice. So those who got completed, please relax. Yeah, very nice. Good work, all of you. Good work here. Now tell me, any doubt in this? Without execution, up function cannot leads to deadlock. From any other doubts from anybody? So I hope so. You're all clear. No doubt in this. No doubt, na? So I'm going to next question. So what is the final answer? Final answer is what? Somebody is guessing from YouTube. Yeah, Samiksha, explain. Yeah, explain please. Okay, please listen. Please listen carefully. Yeah, yeah. Thank you. Please see S is equal to 1 and T is equal to 1. So if I execute P or if I execute Q, parallelly if I execute, what will happen? So down of yes, I can do 1 of 0. So I'm going to next line. And here he said that down of yes. Parallelly it is not possible now. Please observe carefully. So when P performs down yes, Q must not able to do that because he is going to be under waiting. Or if Q performs initially first line, then P has to wait. For example, if I'm starting Q here that 1 becomes 0, then here what is going to happen? This 0 cannot be decremented further. He is going to be under waiting. Therefore, what is going to happen? Either P or Q can start this process, right? So initial first line, either P or Q only can able to execute. Let me say that P started. So he entered 1 becomes 0. T value, yes, fine, I can able to do it decremental. So 1 becomes 0. So I entered into next line and up s, up of s is nothing but signal of s. So what is the signal of s? Initially it is 0. Now if I am making 1, because your 0 becomes 1. As soon as you make 0 becomes 1, please understand carefully. I may go once again back, please understand carefully, or you are giving a chance to q. Therefore, q can able to do preempt now. So exactly this particular point, after doing signal operation, q got the chance. Then what is going to happen? As you are becoming a 1, then 1 becomes 0. So it is success. Now please observe, down t is not possible. Why down t is not possible? Still you are holding down t value there. So down t is not possible. You are waiting. You are waiting for t value to q. So you are waiting on to p. Now see. So he is under waiting. Now I am saying down of yes. Now it is not possible down of yes. Why it is not possible down of yes? Because already q is a preempted u. Then you are going to wait for him. So 0 cannot be further. Therefore, you are waiting for him and he is waiting for you. And both are leads to what? Deadlock concept. Therefore, what is going to happen? P1 is executed first line, then P2 is executed second line, then P3 also executed third line, then P4 also executed fourth line, then Q1 is executed, then Q2 is executed, then P5 is executed, leads to deadlock. Clear all of you? Friends, so I'm going to next question. Thank you. So 24th question. This is a 24th question. Four shared resources, two processors started at same time. So these are the constraints I want to satisfy. Order, first constraint, then second constraint, third constraint, fourth constraint. Order, it should be satisfied in a order. Then find the number of semaphores to finish the above execution. This is a P1 code, this is a P2 code. And before executing your P1 and P2, those four conditions supposed to be satisfied. So how many semaphores you use in order to satisfy this? Okay. So is it possible with a single semaphore? Is it possible with two semaphores? Is it possible with three semaphores? So I can give you one hint here. You can do toggling. This is what is the meaning of toggling only. First he is giving a chance to P2. Strict alteration he is doing. Please understand carefully. This is the logic you got. First P2 will execute, then P1 will execute. Then again P2 will execute, then again P1 will execute. Whenever you see toggling among the processes, then you know what to do, right? So let us take the poll. 24th. Very nice. So whenever you want to do toggling, you need not worry about this constraint. There is only toggling happen between two processes. Whenever toggling is there, you know what to do. End poll. Okay. So Samiksha Jain is a student of Delhi Technological University. So we are having a good friend with us. Then in front of you there is a one more guy. That's me. Please understand. So there is a one student with us, Samiksha Jain, who is studying in Delhi Technological University. Yeah, now you in front of me, one more person is there who is teaching to you. So I may be the grade then. So come to. So what is your answer? Please understand. So what is your answer? Your answer, please observe that toggling whenever you want to do. So whenever you want to do toggling, then you say that one we want to on, one we want to off. So one we want to off, then one we want to on. Bus. So there is a requirement of what? Two semaphores. So two semaphores, you could able to do a concept of this. You can easily, what I mean to satisfy all these constraints using a two semaphores. As there are two processes, as there are only two processes, one is on, one is off. So we are not going to do any kind of progression here. Okay, friends. So come to next question. Please in exam, if you find this kind of question, don't execute all. Please use your logic. What is your logic? Please understand carefully. Toggling only we want to do. Toggling means minimum two semaphores required. One means on, the next means off. So come to 25th question. Please understand carefully. So come to the quiz. So binary semaphore, process PI, one dot dot, nine processes are there, and they are executing wait operation, critical section, B operation. So what is the number of processes that are in suspended list at an instance of time? Please answer to this question. So I need not tell you what is the mutex initial value. You have to guess. Please understand. You have to guess as you are using. Please read the line carefully, Nishukumar. Read the line carefully. So when he is not talking any kind of value, you need to take the initial values. Initial value. So binary semaphore initial value is nothing but not zero. It's what? 1. Now come to the point. So take the poll. 25th question. How many processes are in suspended list at an instance of time? Good work. So doing very well. Very nice. Now tell me friends, any doubt here? So you got 8, but in binary 0 and 1, so I confused. So you got 8, why? Because it is a mutual exclusion. Whenever one process is inside, then other process must not be done. Therefore, whoever is coming next, they are all going to be under what? Suspended list only. We know the wait operation and the signal operation of a binary semaphore. So based on that, so you are guessing that only one process we keep in inside. When all the 9 processes come, we will keep them others outside. Therefore, 8 process. So come to 26th. What happens if s is equal to 0? Nothing happen. When you are saying s is equal to 0, you know the down operation. The down operation is nothing but if s is equal to 1, then we can say that s is equal to 0. Then else what is going to happen? You need to suspend all of them. Clear? So in that it is 9. So come to this. This is one of your previous gate question. So take the poll 26th. So P10 code is a different. Please understand. Process 10 code. This is the code for process 1 to 9 same code. Process 1 to process 9 same code. But process 10 code is a different. What is that? It is a view mutex. Starting line is only view mutex. Then a critical section. Then again view mutex. Now you see there are 10 processes are there. Then 1 to 9, the left side piece of code, process 10, this is the piece of code. So how many you can able to allow? So what is the largest number of processes that can be inside the critical section at an instance of time? Yeah, tell me friends, any doubt in this? Yeah, infinite. Any doubt in this friends? Any doubt? So when I'm saying P of mutex, it's a fine. Then I'm saying 1 becomes 0, but he is making increment here. So as P10 is doing increment, then the P10 is keep on doing increment. So as the mutex value is keep on increment, therefore you are going to get those many mutex variables. So I'm going to generate a multiple mutual exclusion variables. So P10 after executing 10 times, then it is going to generate 10 mutex variables. So those 10 I can able to pass to others. So let us go to next question. So what is your answer? Please tell me. This is important point. So answer it 27th. Only 30 seconds. So very simple question this is. So I hope so you do not have doubt. So why? Because we are saying here that the code is in a such a way that binary semaphore means it guarantees a mutual exclusion. Mutual exclusion means only one process is going to be allowed. This is a repeat, but earlier one is based on a number of processes are in suspended state. This is the difference. So 28th question. So answer this. I want to generate the string must not consist a substring of 0, 1 to the power of n, or 1 0 to the power of n1, where n is odd. So I'm saying that, for example, n is equal to 1. I should not consist, a string must not consist 0 1 0 or 1 0 1. Please see, this is one example. If I am saying n is equal to 3, you cannot say that n is equal to 2 because he said that n is odd. So therefore, n is odd 3. That means 0 triple 1 0 or 1 triple 0 1. A string must not consist this order. You should not get this order of string, but others I can able to get it. Others you can get it in the sense you can get 0 0 1 1. It is a sanction, or 1 1 0 0. It is a sanction. So this kind of order I need, but a string must not consist this. This string must not consist this. So in place of w, x, y, z, what are the semaphore values you are going to keep, so that you are going to generate this kind of output. Okay. So observe carefully. This is one of your previous gate question. Let us take the poll of 28. Please see, toggling he mentioned. Toggling is very important. Toggling only. So S and T initially 1, S and T initially 1, S is only initially 1, S and T initially 1. So let us take the poll 28th. So I will give you some time. Please do. Very nice. Good work. Rama, Manila, and others. Very good. Tapashvi. Superb. Surabhi. Fine, fine. Last 5 seconds. Please come up, come up. Don't give up. Yeah. So, friends, you have to solve on your own. You have to solve on your own. So, please solve this. The option is that option C is the correct answer in this case. Option C is the correct answer in this. So, come to next question. So, we are coming to reader, writer, producer, consumer problems. Yeah, Samiksha, Vanilla is my student only. He is my student since first year, and she is already gate cracker. She is trying for ISRO and BARC examinations. Yeah, come to this question. So, which of the following conditions are true as far as readers and writers problem concerned? So let us take the poll. 29th. You know the conditions, right? Please see that conditions. Reader writer, I said already in the last sessions. Those conditions, please keep it in mind and give me the answer of 29th question. So ready? 30 seconds time. Very nice, Kiran. Others, please respond. Don't take this much time. Very nice, very nice. Good, good. Last 5 seconds. Hurry up. Nice, friends. So you can see your scoreboard. Very nice, all of you. So you got option B. What is option B? A is only one reader at a time may read. No, multiple readers are allowed in reader's writer. Please understand. Multiple readers are allowed. Only multiple writers are not allowed. One reader, one writer not allowed. And multiple writers not allowed. Remaining all you can do. So option A, only one reader at a time may read the file. No, you can have multiple readers. Okay? So therefore, only one writer at a time may write the file. Okay, this is satisfied. Any number of writers may simultaneously write the file. It is not possible. Any number of readers may simultaneously read the file. Yes, this is true. Let me cross check. And if a writer is writing a file, no reader may read it. Yes, this is also true. And if a reader is reading a file, no writer may write it. This is also true. So what is our answer now? B, and B is a correct answer. And next one, D is also correct answer. And next one, E is also correct answer. And next one, if a reader is reading a file, no writer write it. So it is also right. So only one reader at a time may read the file. So this is what? This is a false. Multiple readers are allowed. So our answer in that case, 29th one, BDEF only. So A is not satisfied. Yeah, thank you. Thank you very much. So option B is the correct, guys, all of you. Thank you. So let us go to 30th question. So this is very easy. 30th question. Very nice. So we need not discuss about this. Very nice. So whenever you talk about the multiple processors are sharing the data, then there may be a chance of what? Race conditions. In order to implement the race condition, then there is a requirement of what? Critical section. Yeah, 31. This is also a very simple question. Hurry up, make it fast. So this is also a very simple question. 31st. Answer, jaldi answer. Very nice. Good work. Very nice. So option A is correct answer. 32. Yeah, think properly this question. Think properly. Yeah, permanently wait means it's no, Ajay, please see. Deadlock means two or more process must bidirectionally waiting each other. If I am waiting for a single resource, then infinite time, that is a starvation. Deadlock means what? Bidirectional required. Cycle must be formed. So please observe this question carefully. Inter-process communication mechanism. Ready? So 32 question poll. Answer carefully. I want to do inter-process communication. Yes, very nice, all of you. Superb. So when you want to do inter-process communication, we are going to use two important system calls. Two important system calls. What are those two important system calls? Yeah, no. Yeah, superb, all of you. So I will tell you there are two important system calls in order to do inter-process communication. One is a remote procedural call, the other one remote method invocation. It is not a mission invocation. Remote method invocation, RMI, RPC. Two are there, RPC, RMI. If it is RMI, it is a remote method invocation, it is also correct, but it is given a remote mission invocation. Okay, option C is correct. Go to 33 question. Please see. So let us take 33 question poll. Jaldi. Very good. Tapashvi. Super. Samir Sharma. Manila. Good work. Ajay. Very nice. Very nice. Then what about deadlock? Where? Which question? Sameksha? 33. The solution to critical section problem is three only. Three properties we want to solve. Mutual exclusion, progress and bounded waiting. We don't talk about deadlock. It must be deadlock free. Please see, it must be deadlock free. So come to next question. 34. Inter-process communication done through. So very fast answer I need. 34. Inter-processed communication can be done through. Very nice. There are two varieties, message passing and shared memory. So using that, you can able to do this kind of inter-process communication. So the answer is messages. Come to 35. Yeah, come to problematic. Think properly. He is asking about Petrosian algorithm directly. So for the program to guarantee mutual exclusion, the predictor of P in the while loop should be what you need to keep it in while loop. There are four answers using a Peterson solution, and we want to satisfy mutual exclusion property. Come to question number 35 poll. He is using a two variables, flag I true, turn J, and while condition we need to keep, then enter into critical section, then flag I false. So take the poll. 35. Very good. Very nice, all of you. So the answer is B. So Ravi, those semaphore lectures, not only semaphore, entire operating system is available in Let's Crack GATE CSE. That is a YouTube channel. Let's Crack GATE CSE. In that playlist, you will find operating system lectures. Otherwise, I will send link. So come to question number 36. Yeah, this is challenging to all of you. This is a very good challenge question. Think properly. 36th question. Four semaphores and four processors. They are executing wait mi and wait mi plus 2. This is mod 4, and signal release mi plus 2 mod 4. This could cause so that's why while doing this problem I am telling you, take four processes P0, P1, P2, P3, P4. Observe carefully. P0 to P4 processes and semaphores M0 to M4, and the processes are executing like this: wait mi and wait mi plus 2 mod 4. Okay, so now is it trying to put you deadlock or not? So take the poll of 36th question. If you have any doubt, don't worry, I will discuss. So 36. Very nice. So please observe carefully how they are acquiring the semaphores. The way they are acquiring the semaphores will give you deadlock or not, bus. Very nice. So let us see the scoreboard. Yeah, any doubt here? Any doubt? So we know P0 gets first I is nothing but 0 only. I am taking I is equal to 0. Yeah, let me check. So I is equal to 0 means m0. Then weight mi plus 2. Mi plus 2 means 0 plus 2 mod 4. 2 only, m2. This is about p0. And p1. What about p1? So p1 I is equal to 1. This time I am taking. So therefore m1 and 1 plus 2, 3 mod 4, m3. And the next one is I is equal to 2. Where I am saying I is equal to 2, then this is a m2 and 2 plus 2 mod 4. So that is nothing but 4 mod 4. It is m0. Please observe. Then p3, that means I is equal to 3. Therefore I am acquiring m3 and 3 plus 2 mod 4, that is means 5 mod 4. 5 mod 4 is nothing but 1. So 5 mod 4, it is nothing but 1. Now I is equal to 4. So 4 means I am acquiring m4 and 4 plus 2 mod 4, that means 6 mod 4, it is m2. This is how they acquired the semaphore. Now you tell me, is there any deadlock? Is there any deadlock or only starvation? Is there any deadlock or only starvation? Yes, you can simply say like this. Please understand. Here to here, please observe, and here to there. Simple answer. So M0 is with the P0 and P2 is requesting, and M2 with the P2 and P0 is requesting. Simply it performed deadlock. This is what is the meaning of deadlock. Ajay and others, please see, listen carefully. So two processes are waiting for each other bidirectionally is the concept of deadlock. If they are waiting sequentially, then it is called as starvation. So come to question number 37. Answer now. Same question, but this time I am taking mi plus 1 mod 4. Is it a deadlock or not? You do the same process once again. P0, P1, P2 and P3 and P4. Yeah, we will see question number 36. Please solve question number 37. So mi plus 1 mod 4. So is it a deadlock or no deadlock? So take the poll now. Question number 37. 37. So I'm guessing. So don't worry about the poll result. Just I'm guessing. You please confident yourself. Is this cause a deadlock between P1 and P2? Please observe carefully. Is this a deadlock between only two processes, P1 and P2? He is not talking about others. So very nice. So many of you are responding excellently. So M0, this is M1, and this is a M1, and this is a M2, and this is a M2, and this is a M3. Please understand, he is talking about P1 and P2 only. So there is no doubt because M1 and M2 different semaphores and M2 and M3 different semaphores. Yeah, I'm going to wait here. Please observe. Ajay, please observe this question carefully. So this is what Ajay's doubt. Please observe now. So Ajay doubt is that is there any deadlock between P1 and P2? Please understand. So P1 is holding M1, P2 is holding M2, and P2 is waiting for P1 is waiting for P2. That means what here? Because I am waiting for you, but P2 is not waiting for P1. I am not waiting to you because I am using a different semaphore. Therefore, there is no deadlock, but you see that the starvation to P1, please understand, P1 is under starvation. P1 is under starvation to P2. Unless and until P2 releases, P1 has to underweight. Clear na, Ajay? Clear, Ajay? So I'm going to last question of the day. I'm going to last question of the day. Yeah, this is your reader's writer. So reader code is given and writer code is given. In S1, what are you going to keep? S2, what are you going to keep? S3, what are you going to keep? S4, what are you going to keep? There are answers are given here. Which option is correct? Read count 0, writer semaphore 1, mutex semaphore 1. So recollect the readers and writers. So already it is started with wait mutex. So let us take the poll. So ready, all of you? So I am starting the poll now for 38th question. Very good. Santanu, Abhishek Mohanty. Thank you all who staying for 2 hours of mega quiz. I thought that you people could able to stay or not for 2 hours, but luckily this today quiz session is a grand success because of you. The all credit goes to all the my lovely friendly students. So very well, all of you. Good work here. So now you're all confident interprocess communication, that is a process synchronization. And please be practice one more. I'm going to come with one more quiz on memory management this time. So I will tell you a day. So because the memory management is also one of the tough concept, we do quiz on memory management after a few days. So tomorrow our session is at 2 p.m. So tomorrow 2 p.m. we are going to discuss about page replacement algorithms. Why need of a page replacement? That's from starting. I will start with that. Why there is a need of page replacement and what are the algorithms are there, and some of the questions also we discuss. And evening 7 p.m. again there is a special class on demand paging. So tomorrow there are two sessions. Tomorrow there are two sessions. One session is on 2 p.m. and one session is on 7 p.m. 2 p.m. session on YouTube, 7 p.m. session on your special class. So don't miss. There are very few classes are left. There are very few classes are left in operating system. So tomorrow two sessions, YouTube one and special class one. After memory management, we will do what I mean to say called quiz on memory management. Thank you very much. So unless you are there, we cannot success the quiz. So many are participated. Really wonderful today's session. I'm very much satisfied. I hope so. You also very much satisfied. If you are very much satisfied, please give a what I mean to say a like and a positive comment on your special class app as well as on YouTube. Also, this session is running. And one more thing is that please take the admission. Please take the admission in an academy and get the benefits out of it. Thank you very much. ఓ మై గాడ్ 2 hours లాగలనా లాగలేనా అనుకున్నాను. సో ఇవాళ 2 hours మనకు కలిసి వచ్చినట్టే. ఫ్యాన్ స్పీడ్ పెట్టి తలుపులు ఓపెన్ చేసే యూట్యూబ్ సెషన్